Hello DP2 students, we are going to look at using differentiation in everyday life. We are going to look at the basic differentiation. So let's look at example 2 on page 530. It says in economics, the marginal cost is the cost of producing one more unit. This can be approximated by a gradient of the cost. Gradient function, another term for differentiated expression. When after we differentiate equation, it is also called the gradient function. So gradient function of the cost curve, the gradient function is the differentiated function, right? Okay, it says a company produces motorcycle helmets and the daily cost can be modeled by this. So this is the cost of producing the helmets, right? You can so if I draw the graph, the x values will be between 0 and 150. The maximum and the minimum value for the x-axis would be 0 to 150, right? We can produce as a now the cost, we have to incur the cost when we produce no helmets, 0 helmets, or maximum of 150 helmets, where it says x is the number of motorcycle helmets produced and c is the cost in USD. So x is the number of motorcycle helmets and c will be the cost. It says write down the daily cost to the company if no helmet is produced. That means number of helmets is 0. That means in place of x, I will substitute 0. Once you substitute 0 in place of x, you will see the cost is $600. How is that possible in real life? So in real life, so if there's a factory and people are at the factory, people are working at the factory, there's electricity going on, there's people using the tap, people going to the toilet, there's water bills and other things that they'll have to incur and keep the light running for the purpose of the electricity. So even though on a particular day at a factory no helmets are produced, but anyways we'll have a cost, the total cost for that day would be $600. It's right. Okay, right. So let's look at part B. It says find an expression for the marginal cost. Find the expression for the C dash X of producing the helmet, right? Find the cost. Sometimes it will say marginal cost, which is C dash X. Another word is the rate. Find the rate of change. When it says find the rate of change, that means we have to find the, we have to differentiate, right? The word rate of change, when it's asking us to differentiate. When it's asking you to find the gradient function, that means it's asking you to differentiate. So it says find an expression for the marginal cost C dash of X for producing the helmets. That means we want to differentiate. If this is my original expression, I will differentiate. So differentiating can be done like this. 600 will be differentiated to a 0. 7x will be differentiated to 7, or this can be differentiated. The 3 will go and multiply to the number in the front, which will be that, and we will minus 1 from the power. Okay, you can even use your calculator to differentiate. You will type that on your graphs equation and then have the derivatives done. You have a video on how to differentiate using your calculator from your last activity. Please have a look at that and know how to use it. That will make your work easier. Okay, part C says find the marginal cost of producing 20 helmets and then also 80 helmets. Marginal cost, that means I have to substitute this 20 and 80 in my differentiated equation. There you go. That was my differentiated equation there. And I've substituted 20, I get 6.88. I've differentiated 80, I'm getting 5.08. Okay, and it says state appropriate units for the marginal cost. That means I want to pay in USD. It says here pay in USD. So number of helmets USD, the price for the helmets, the cost for the helmets pay USD. So USD per helmets. How much we have to have for one, what's the cost for producing one helmet? Okay, let us now look at example 2. Example 2 says again in example 2 number 2, it says a hammock can be modeled by the function. That's my function. A mosquito traveling in a straight line, the gradient is 11. So once we differentiate and a function, the gradient function, the gradient is 11. So I told you even earlier, the differentiated function can be also called the gradient function. So this time the gradient is already given, the answer is already given, and we have to find the coordinates for point A. So in your last lesson you learned how to differentiate and find the gradient. So the rule for finding the gradient of our function is that we differentiate first and then we'll substitute the value of x in the differentiated equation, right? First you differentiate the equation and then you substitute the value of x in the differentiated. Normally this value of x is given in the question, but now in this practice, in this example, the gradient is given already. The gradient is given is 11. I have to find the coordinates for point x, right? So in this case, in this question it said point A. We have to find the coordinates for that point A. So giving the x value. So in the last activity you differentiated it and then you substituted the value of x in the differentiated equation to find the gradient. Okay, we will still differentiate that. I've differentiated, it becomes this, right? So to find the gradient, we substitute the value for x here. But this time the gradient is given and I have to find the value for x. So answer is given. I'll solve it like an equation. Plus 3 will come as minus 3 times 4 will go as divided by 2. My x coordinate is 2. Can you see coordinate for point A is 2? Now how do we find the y coordinate? Like as well you have been doing in simultaneous equations, any other solving equations, you find the value of x, to find the value of y, you will substitute this value of x in the original. So that's my original. Original is the one that's given in your question paper, right? The original equation. To find the value of y, we'll substitute the value of x in our original equation. Okay, you can see here, we'll substitute 2 in our equation. There you go, and you got find the coordinate as 10. So once you find the coordinate of point A as 2, the y coordinate can be found by substituting the value of x in the original. You get the coordinate as 2 and 10. Thank you.